In this lecture, we're going to learn about PANDAS, which is a Python library providing data structures and data analysis tools. We start the notebook by importing PANDAS as PD. The most useful data structure in PANDAS is the DataFrame, which is similar to an Excel spreadsheet. To describe the DataFrame, we will first describe the dictionary, a built-in Python data structure. Here is a dictionary containing greenhouse gas emissions in tons per capita for several European countries in 2016. The data is taken from the Eurostat database on climate change and can be retrieved from this URL. The dictionary associates unique keys, that is, the country names, with the emission values. The analogous PANDAS data structure for the dictionary is the series. A series can be built from the list of dictionary values and the corresponding keys. It is also possible to specify a name for the column containing the data, in this case the year 2016. The same series can also be created directly from the dictionary. When we do that, the keys of the dictionary are automatically identified with the indexes of the series. We can see that the type of the numerical values is set to float 64. Let's check the type of the list of values in the series. It is a NumPy array. This allows for fast data processing, for instance using broadcasting and vectorized operations. Here we use the NumPy function multiply to convert from tons per capita to kilograms per capita. If we create a series providing only the numerical values, these will be associated with integers starting from 0, which are the index locations. There are two ways of finding the values associated with a given index in a series. With the attribute loc, we specify the index label in squared brackets. Whereas with iloc, we specify the integer of the index location. Here we have a new series containing data on the emissions in 2014. A data frame can be created from two series. Since the data for 2016 was missing for Italy, in the corresponding field in the data frame, we can see a not a number. The same data frame can be created starting from the dictionaries. If we want the rows to be the countries and the columns the years, we can transpose the data frame. Alternatively, we can create the data frame from a dictionary of dictionaries. For row selection, we can use the loc and iloc attributes as we did for the series. For column selection, we can directly use the indexing operator on the data frame. The same can be done with loc and slicing. We select all the rows and we specify the column name separated by a comma. We can also select a list of rows or a slice of rows. The same can be done with iloc by specifying the location-based indexes of both rows and columns. To change a single value, we simply index the row and the column and equate it to a new value. Slicing and indexing can also be used to add new rows and columns. For example, we can add a new row for the emission values for Germany. And we can also add a new column for the emission values for all countries in 2006. We can also exploit broadcasting to set all entries of a column to a default value, like we do here by assigning none to the greenhouse emissions of all countries in 2020. To delete rows or columns, we can use the drop function. This function returns a copy of the data frame. In fact, we can see here that the original data frame is unchanged. If we want the deletion to take place on the original data frame, We can do so by setting the inPlace parameter to true.